Hear me? All right, so today's lesson is going on molarity and dilutions. If you're watching this recording, you are my second and maybe sixth grade class. So today's topic is about molarity and it's also over dilutions. So molarity. There's a familiar word or familiar root in that word, mole, M-O-L, which refers to this mole over here. Okay, it's been a while since we've gone over the mole, but it's pretty important. That concept never goes away. We're always going to be using it over and over again in chemistry. So the mole is pretty simple. This guy right here. That was ugly circle, but whatever. The mole is basically how we count or measure the amount of atoms, molecules, particles in chemistry. The same way a baker, sells a dozen donuts, which is 12. In chemistry, we use a mole to measure quantities. Okay, just a basic measurement or basic unit measurement for atoms. But they're really, really tiny, and so we need to come up with a scale that's appropriate for that. So the way 1 dozen equals 12 something, 1 mole is going to equal Avogadro's number, okay? Which is this guy over here, 6.02 times 10 to the power 23, okay? I think I just sneezed. Okay. That's fine. I can look that. So if a dozen means 12, 1 mole means 6.02 times 10 to the power 23. Okay, so 1 mole of carbon, 1 mole of plutonium, 1 mole of sodium chloride. They will have the same number of particles / atoms. Now, the molar mass was a game changer. Okay, the molar mass made it much easier to measure the mole. Okay, instead of counting 6.02 times 10 power 23 number of atoms, you can just measure out that in grams, okay? So for instance, let's say you need a mole of carbon for, actually, let's make it fun. Let's say you need a mole of plutonium to build a bomb, okay? I don't know how much plutonium you need, but I'm just guessing, okay? Let's say you need a mole of plutonium to build a bomb, okay? Do you want to count 6.02 times 10 power 23 number of plutonium atoms? No, I don't think so. By the time you're done counting, the Earth will probably be dead by then. I don't know. But anyway, you get the point. You don't want to count that many number of particles. So it's a shortcut. What do? You measure it in grams. And how you do that? Well, it's pretty easy. You simply look up plutonium's atomic mass on the periodic table, and you simply change it to grams. I don't know it off the top of my head, but it's probably like 200 something grams. Let's try something else. Let's say you need a mole of carbon. A mole of carbon will be 12 grams. So plutonium will be like 200 something. Carbon will be 12 grams. Different masses. One's obviously heavier than the other, but what do they both have in common? They both have the same number of atoms. Same way, 1 dozen donuts weighs more than a dozen flowers. Yes, they weigh differently, but they both have the same number. 12 flowers, 12 donuts. Now, for today, we're not really going to focus on the number of atoms. So, relax. We're going to focus mostly on the molar mass, going from grams to moles, because today's topic is about molarity. And let me kind of jump ahead to a couple of slides. Let me jump ahead over here to our actual notes. So what is molarity? It is quite simply the molar concentration or the number of moles of solute per liter of solution. Basically, it's a fancy way of saying how much stuff have you dissolved in water or a solution, so to speak, okay? How concentrated is your solution, okay? So we've sort of covered this in a sense. We use general vocabulary. We use the words unsaturated, saturated, and supersaturated. Those are kind of scale. We said unsaturated was like unsweetened tea, just no sugar in there at all. While saturated was the balance, like the perfect amount. And supersaturated was just way, way, way too much, just too much. Okay. With molarity, we can assign a value to those kinds of concentrations. So let's look over here at this picture where we have a gradient or a scale of, shades of blue or gradients of blue. We have very dark blue and very light blue, okay? If you guys were making like some sort of Kool-Aid mix, the dark blue will be the one that has like the most amount of Kool-Aid mix dissolved in there. It'd be really strong, super sweet, like disgusting actually. While the light blue one will be so watered down that it literally just water with like a hint of food coloring, okay? While the one in the middle is probably the perfect amount of Kool-Aid mix and water, okay? So these numbers here, 100, 10, 1, 0.1, and 0.01 are the mole concentration. 1 is like the starting point, the balance point, so to speak. The higher number is, the more concentration you have in your solution. The smaller number is, the less concentrated it is. Because molarity is just, it's all about ratios. As it says here, it is a ratio between your solute and your solvent, or basically how much you have dissolved compared to how much of that solution you actually have, or your volume, okay, so to speak. So your formula is actually really easy. There's not much to it at all. It is simply going to be the moles of your solute, or what's being dissolved, divided by the liters of the solvent or the liquid that is doing the dissolving. And the liquid that is doing the dissolving tends to almost every time literally be water, okay? We don't really use anything else. So most of these problems will just involve water and something being dissolved in it. You want to figure, all right, what's the concentration of the solution when you mix this compound in water? That's literally what it is, okay? So we need to know how to find moles though, okay? That's important. That's a very important concept that we need to review. So the second slide is your review of the mole. And I do apologize, I made an error in these notes. So these notes are from last year when we first started going virtual. So a lot of work here is actually already typed out. But unfortunately, I realized that I forgot to include part 2 for these examples. So one thing you need to review quick is how to go from grams to moles, because when you have these molarity problems, they're going to go on the lines of, hey, I have like a certain number of grams of this compound and I want to dissolve in water. What's the molarity? Well, grams and liters don't really tell you much, but moles over liters tells you a lot of information. So we need to review going from grams to moles. And how do you go from grams to moles? We simply do what? We divide by the molar mass, which means what do we need to define? The molar mass of compounds, okay? So example 1 is over here. Let's say I have 1.5 grams of aluminum chloride, which is a compound, and you want to convert it to moles. So part 1 I have typed already, which is like the mole mass of aluminum chloride. Part 2 I have to draw because I didn't type it out. I forgot studying. So what do we do here? So to find the molar mass of aluminum chloride, we list out the elements. Aluminum chloride, Al, or aluminum and chloride, Al, Cl, right? We list out their quantities. We have 1 aluminum atom in here, and we have 3 atoms of chlorine. You multiply by what's their atomic mass. So aluminum is 27, chloride is 35, right? So 1 times 27 is 27, and then 3 times 35 is 110. Add those up, and your atomic mass of aluminum chloride is 147 grams. This right here. This is molar mass of AlCl3, or aluminum chloride. The part that I did type out, which is me dropping the ball, is how to go from grams to moles. And that's really easy. Not much to it at all. Let me draw this little line here. All right, so for part 2, we need to go from grams to grams to moles, okay? How we do that? Well, we divide. Okay, we divide. That's ugly. We divide. So we take the grams that we have here, and we divide by the molar mass, and that's going to be your answer. So we do 1.15 divided by 147. I've been doing this all day, but I do not have the answer memorized, and my handwriting is really ugly right now. I'm trying to be pretty. So do a calculator real quick. It will just be like this. So it would be 1.5 divided by 147, and your answer is going to be quite simply this. It will be 0.01 mole. Okay, that's all you gotta do. This has to come quick. You should not be struggling with finding the molar mass. You just simply list out your elements, list out how many quantities have each element, multiply by their molar masses, and then you add those up, and that's the molar mass of your compound, and that's all you gotta do. So now let's do the other example real quick. Let's say I asked you guys that I want you to find the number of moles that you have in 30 grams of NaCl, which is sodium chloride, okay? So NaCl, one of each. Na weighs 23, Cl weighs 35, add them up, you get 58. So 58 is the molar mass of sodium chloride. But now you want to figure out how many moles are in 30 grams. So we go once again from grams to moles. We divide. So we do 30 divided by 50. No, 58, sorry. 58, it's basically going to be like 0.5, if I'm correct. 30 divided by 58. Yeah, it's going to be 0.51 moles. So pretty easy. This did take very long. To figure out the number of moles in each amount of grams to like a minute, you know? Find the molar masses, add them up, and then go from grams to moles. It's pretty easy, okay? Now, let me kind of jump ahead to steps for solving for molarity. So solve for molarity, you gotta do 4 things. Step 1, you need to find the molar mass of your compound, okay? Because I'm gonna tell you the number of grams mixed in there, but not the molar mass. So find the molar mass. Second, convert from grams to moles, like we did over there in the examples. Now, part 3 should be pretty easy. Convert from milliliters to liters, okay? And I'll scroll up 2 slides to show you guys how to do that real quick. And then lastly, the last step is to use a new formula to find molarity. So what do? You do moles divided by liters. So step 2 divided by step 3. Real quick, a little refresher. To convert from milliliters to liters, all you gotta do is divide by 1,000. That's all it takes, okay? So let's say I wanted to ask you guys to convert 420 milliliters to liters, divide by 1,000, 0.42. Convert 830 milliliters to liters, divide by 1,000, 0.83, okay? So here you go. So looking for you guys, the first 2 are typed out, okay? Because it's from last year. So I'm just gonna go over the steps. So there's 4 steps here, like up here. Step 1, find the molar mass of your compound. Step 2, grams to moles. Step 3, change milliliters to liters. And step 4, find molarity. So this is the kind of problem you're gonna see more or less. Find the molarity of 1.75 grams of sodium chloride in 350 milliliters of water. I have like barely 2 grams or a little under 2 grams of salt. I'm going to mix in 350 milliliters of water, and I want to figure out mathematically what the concentration is. Okay, what's the ratio of salt to water, basically? So, what do we do? Step 1. Hey, there we go. Step 1. Find your molar mass of sodium chloride. So what do? NaCl, one of each, multiplied by their masses, 23 and 35 respectively, and the molar mass is going to be 58 grams. Okay. Next one. Convert from grams to moles. And what do? I even type that right here. Divide by the molar mass. So take a problem, or the number from the problem, which is 1.75 grams, and divide it by 58, which is the molar mass of sodium chloride. You do that, and you get 0.03 moles of sodium chloride. So far, not bad at all, right? This is pretty straightforward. Step 3 should take a few seconds to do. We want to change 350 milliliters of water to liters. What do? 350 divided by 1,000 gives you 0.35 liters. And lastly, the last step is the new equation, which is molarity, which is moles over liters. So what do? 0.03 is a mole of sodium chloride. Divide by 0.35, all right? And that will give you the answer of 0.086. Now, you don't need to write molarity for this. Just simply write capital M for moles, okay? Or for molarity. Sorry, my bad. I got mixed up. You don't need to write 0.086 molarity. Just write 0.068 capital M, and that will represent the molarity of the solution. Okay, that's all you gotta do. That's all it takes. Just a few easy steps. The most important part is to make sure you have the moles of grams, or you convert your grams to moles. So that way, when you convert your milliliters to liters, you divide those two numbers and you're solid. That's really all it takes. So let's cover another problem. Example number 2. What we do now? A different problem. This one goes like this. It's saying find the molarity of 2.35 grams of magnesium chloride dissolved in 200 milliliters of water. The steps are the same, just a different compound. Step 1 is we find the molarity or the molar mass of magnesium chloride. So MgCl, those two separate compounds, 1 magnesium, 2 chlorines, multiply by 24 for magnesium, multiply by 35 for chlorine, 24, 2 times 35 is 70, add them up, and the molar mass of magnesium chloride is 94 grams. Not bad. Down here, we must convert 2.35 grams of magnesium chloride to moles of magnesium chloride. So what do? 2.35 divided by 94 will equal 0.035 moles of magnesium chloride. So we have our moles now of magnesium chloride. It's important because it's molarity, so we need to have moles. The next step is easy. Changing 200 milliliters of water to liters, divide by 1,000, you get 0.2. And lastly, down here is where we wrap things up. To find the molarity of magnesium chloride dissolved in water, you do your moles, which is 0.025, divided by 0.2, and that will give you an answer of 0.125. Put a big capital M to represent concentration. That's it, y'all. That's all there is to it. This isn't that hard. It's 4 easy steps. Molar mass, moles, or I should say grams to moles, change milliliters to liters, molarity, and you're done. Now, I have 2 more I can do, but I'm going to save number 4 for review on Wednesday, okay? So I will write out number 3. It's saying find the molarity of 4.2 grams of calcium chloride in 690 milliliters of water, okay? So you want to figure out what the molarity of this solution is. So step 1 is find the molar mass. So we have calcium chloride, okay? CaCO2. We have calcium, we have chlorine. 1 calcium, 2 chlorines. Calcium weighs 40, chlorine weighs 35. 1 times 40 is 40. 2 times 35 is 70. Add these two up, and that's an ugly number. And you get 110 grams as your molar mass. Okay? I can do it down here. I can squeeze in here. This isn't too bad. So then we go over here to step 2, which is we go from grams to moles. So what do? We're going to simply divide 4.2 by the molar mass, which is 110. So we do 4.2 divided by 110. And I will give you the answer of 0.3. Yeah, we'll agree, okay? Yeah, we'll like that. Just keep it simple. 0.03, okay? Step 3 is easy. Go from milliliters to liters. So what do? We do 690 divided by 1,000. That will give you 0.69 liters. And the last step is molarity, which is going to be this. You do moles over, sorry, zoned out, over liters, moles over liters. And so we take our moles from over here and our liters from over here, and this we divide by, okay? So we just do that. Actually, I'll make a different color so you can tell where it came from. I'll use a light blue. So light blue, I'll make that yellow. So there we go. And so we do 0.3 divided by 0.69. And your answer will come out to be divided by, it would simply be 0.43 and make it a capital M for molarity. And that is a concentration of calcium chloride in that set amount of water. That's it. That's all there is to it, okay? So now I want to go over the next topic for today and the last topic of this unit, which is dilutions. And dilutions are pretty straightforward. Dilutions are basically watering stuff down. That's all it is. You have a very concentrated solution and it's too strong, so you're literally watering it down to make it less strong, less concentrated. It's like you made a soup, it's too thick, you water it down to so that way it's not as thick, you know? You made Kool-Aid or chocolate, it's too thick, too sweet, whatever. You add some water to it so it's not as strong. Okay, that's all that there is to it. Okay, the fancy definitions on there you can see it. You're basically reducing the concentration of reducing the concentration of solution by simply increasing the amount of solvents. Um, which is basically pouring more water or whatever does dissolve and you add more of it to there. Okay, so in this picture over here, we have a very concentrated solution because the particles are very close to each other. You add more solvent, which tends to be water, and look here, they're more spread apart, which means they are now less concentrated. So there you go, you water it down and it's less concentrated. So your formula to do this is actually really easy. Yeah, there's a math equation to do this. It's pretty easy. It's your initial concentration, which we the original molarity, multiplied by the original volume will equal the new concentration multiplied by the new volume, okay? Because look here, there was obviously a change in volume, okay? So you're solving for something, the volume of this, the volume of that, the molarity of this, or the molarity of that. You're solving for something, okay? And so here are two examples, okay? So let me quickly draw a visual representation of what we're doing, okay? So you have an idea. We have a solution, right? It's like very little amount, very, very strong, and you simply want to water it down and also increase your volume, okay? So little amount, strong blue, higher volume, light blue. This is what you're generally doing when you do dilutions. So in problem one, it's saying that dilute 5 molarity to 10 milliliters at a concentration of 1 molarity. What we're trying to solve for here is what was the original volume at the original concentration before we diluted it to 10 milliliters at 1 molarity. So your formula is quite simple. It is M1, M1, V1 equals M2, V2. You have 4 variables. M1, V1, M2, V2. M1 is the original concentration, which will usually be the number with the bigger M. That makes sense, okay? Or the yeah, you know what I meant. Okay, it's the M with the bigger number, which in this case is 5M. You go from high concentration to low concentration, okay? We don't know what the original volume was. We're going to solve for that. We know that our new concentration is 1 molarity or 1M, and your new volume at the end was 10 milliliters. Okay, so like every math problem, we plug and solve. So we do 5 times V1 equals 1 times 10. That's easy, okay? So 1 times 10 is 10. 5 times V1 is still V1. I'm cutting a little tight here, but I'm going to divide each side by 5. Divide each side by 5. The 5's cancel. Guys, what's 10 divided by 5? It's 2. So the answer is 2 milliliters, okay? That's it. That's all it took. It is simply 2 milliliters, okay? So that means that we took 2 milliliters at concentration of 5 molarity and we diluted to 10 milliliters and the concentration is 1 molarity. Okay. Let's do the next. Oh, what the heck? Let's do the last one and we can wrap things up. Okay. So we have a solution of 1 molarity. We want to dilute it to 0.5 molarity with a volume of 10 milliliters. Okay. So we want to figure out what's the original volume before we dilute it. So similar scenario, M1 V1 equals M2 V2. M1 V1 M2. Yeah, it's actually a little more. M1 V1 M2 V2. Okay, so our original concentration is 1 molarity. We don't know what the original volume was. The new concentration is 0.5 and the new volume is 10. Plug and chug. So 1 times 10. So what is 0.5 times 10? It's 5. And 1 times V1 is actually just going to be V1. That's your answer. V1 was 5 milliliters. Okay? And so that's today's lesson on molarity and dilution.